Good day, I am Ms. Visser, and today we will be looking at the sine rule in trigonometry. Now the sine rule in trigonometry is used on triangles that is not 90-degree angle. Remember, with a 90-degree angle, we will use Pythagoras. Remember, reasons, reasons, reasons. Very important. Okay, but today, not this. We'll look at triangles like this one, or the acute or the obtuse triangles. So let's get started. For the sine rule, okay, this is a formula. This formula, you should know like this. When I wake you up late at night, you should know it. Okay, so we now will look at the proof, don't stress, but we'll see that it's A over sin A, B over sin B, or C over sin C. Why it is like this is A and C and B are the angles. So any alphabet letter that is a capital letter, that is an angle. The small letters like A, B or C, these are the length of any of these sides. Woo! Any of these sides. Okay, so let's see. These are two formulas, but you can actually make it one, okay? So you have this one, but this one can also be written as this one. Why? Because if you like, say for instance, A is, let's only take this. A is sin A times B over sin B. You see what I did there? I only multiplied it here because then it's not divided anymore. And then I can take it sin B to this side, so it would be A sin B is sin A times B. Sorry for my handwriting. And then you just divide it. So you get this equation from this one. So you see that it is sin B, and you divide the B over here, so B is sin A over this one, divide there, A. You see this? And this? They look the same. Just a little switched up, but that's okay. Okay, let me just get something to wipe this off to go on with our proofs. Okay. I hope it's from this stage where we go on. Yes. Okay. Very important to notice. This is the rules for the sine rule. You get it? Rule for rule. Okay. So you can only use the sine rule if there are two sides and an angle. Like side, side, angle. Not side, angle, side, 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 angle. Okay? Or the second rule that you can use is two angles and a side. I'll demonstrate it now. Two angles and a side. So this would mean like angle, like you have C and you have angle A and you have a side. Or angle, side, I have that one, and then angle over here. Okay, so let's do an example, then we'll go to the proofs. Just for matter of time, take away this and take away that, then we'll get the example from my laptop. Let's see here. So, any example would be, let's just make that a C over there. So this AC you get as 3 centimeter. This is just an example. It wouldn't always be 3 centimeter, just an example. Okay, 3 centimeter, you have 67 degrees for angle C, and you have 9,2. We are working with commas over here. 9,2 centimeters for length AB. You see what we have here? We have a side, another side, and an angle. Okay? You see, this is this rule that's being applied here. So always what you want, You want an angle with an opposite, and you want an angle, but we don't have an angle, so a side with an opposite. You only need two, because you only need two to fill in here, to fill in the gaps, to substitute. Okay. So let's see what we need. Let's say we need angle B. Okay, what's angle B? How would you get angle B? Angle B, you would then use this. Okay. So angle B, you want angle B, so we'll start with, not the M. Sin B over B. Why do I write it like this and not B over sin B? There's no real mathematical reason for this. It's actually for simplification reasons. If you write it as B over sin B, then you're going to need this one. So simplification, you're going to have to take this above the fraction and then work it out from there. So it's just an extra step. So you can do it like that. No reason not to do it, but I like the faster method. You don't have a lot of time in maths to complete everything. Okay. Okay, so we have C. Okay, so we're not going to use A because you don't have anything about A. You don't have the side of A and you don't have the angle of A. So this is C and this is B. So we'll say sin and the angle is still on top. Remember, all the angles go together at the top. It's not going to be randomly a C on the side. It's sin C. Okay, over C, and all the sides lengths are then at the bottom. Okay, we take it from here. Then, you see, we don't write like that. We don't go like sin B then. This is already an equation. You don't really have to escalate on what's that in English. Can't remember now. But okay, you don't have two of these in one. Okay, so sin B, we don't have B. You see? You just write B. It's in the place of another number. Okay, sin B over B, so it's 3 centimeters. You don't have to write a centimeter, but remember, at the end of your answer, write the centimeter. We're going to get a mark for that. Okay, sin B. Then sin of 67 degrees. If you were now with me here, I would ask two learners to please get that form. Okay, I'll do it on my own. Okay, so you see here, for simplification, I'm just going to stand here. Simplification from that to here, we're going to say that sin B, how do you get this 3 from under here to the top? You multiply. So you multiply with 3 here, and what you do on the left hand side, you do on the right hand side. Okay, so sin B is 3 times this on this side. So then it would look all better. So I'm just going to make a dot like that. Okay, then you're going to take the inverse. So B is shift sin. Remember, shift sin is another thing. It's not the same as sin. So shift sin, which will take you to sin minus 1, 0,3, I'm just going to say once. And then we get B is 17,4, let's make it 7. Okay, remember to round off your answers. Usually they will ask you for 2 decimals, but in these cases they might ask to the nearest whole number. But if it's not that case, don't stress about it. You can just write, if they say the nearest whole number, you get 17. Yeah, this is in 17 degrees. So the proofs would be in the next video. Please check it, and thanks for watching. Bye!